All right, this is Ken Roosevelt. We're going to try to talk about central limit theorem using this example from the book, page 326, number 9. It talks about the cost of dog ownership. The average yearly cost per household of owning a dog is $186.80. It's pretty cheap. Suppose that we randomly select 50 households that own a dog. What is the probability that the sample mean for these 50 households is less than $175? Assume the standard deviation is $32. Okay, so first thing we got to do is look back. And what does the central limit theorem say? Basically, the idea of this chapter is if a if a sample is normally distributed already, then if you start taking samples, or if a population is normally distributed, and you start taking samples from it, then the distribution of the means of those samples will be normal as well. So, so basically, you do a number of experiments. You may get different means in each experiment, but the means will be normally distributed. Um, and it's also true even if the population isn't normally distributed. And you'll notice up here, it doesn't say anything about the population being normally distributed. Um, And when it doesn't say that the population is normally distributed, you have to make sure that they're doing um, enough trials. Uh, doesn't say. And the number of trials you have to look for is a minimum of 30 trials. So a minimum of 30 trials. And even if it's not normally distributed, after 30 trials, the means from each one of the trials will be normally distributed. So that's what we're going to work off. What is the probability that the sample mean? We're trying to find the probability that the sample mean will be of a certain value or less than a certain value, right? Yeah. So first thing you need to know is that the sample mean, where's my pen? There it is. That the sample mean is equal to the mean. So that is 170, whoops, 186.8. And the standard deviation of the sample means will be equal to the standard deviation for the population divided by the square root of n, where n is the number of trials. So in this case, that'll be 32 divided by the square root of 50. Now using those two facts, all right, this is the mean of the sample means is equal to the population mean, and the uh, standard deviation of the means is equal to this formula, you can find a z-score. The z-score is going to be equal to x from your experiment, or the one you're interested in, minus mu over standard deviation for the sample means, which is that normally the z is equal to just this. But when you're talking about sample means, you have to change this to over the square root of n, and you have to change this because we're not looking for one individual value, which would be x. We're looking for the means of the experiment, which is x bar. Okay, so basically you do that, you plug in your values, use your calculator, and then you look up the z-score. So let me finish this off, and then we'll be done. Our value of interest is we're looking for 175 minus 186.80. When you do this in a calculator, you'll want to put that in parentheses, and then divided by parentheses. What are we doing? 32 divided by the square root of 50. So let me pause here for a moment. I'm going to calculate that and find out what it is. I'm getting, as an answer, my z is going to be negative 2.6074. So we will approximate that as negative 2.61. And we'll look that up in the table E. We'll look up positive 2.61, which is 0.4955. 0.4955. So let's see. This is what we're learning. So positive negative 2.61, and this is what I say it was. 4955. Well, we're not interested in greater than negative 2.61. We're actually interested in the z-score. We're interested in the probability that the z-score, actually we're interested, let me go back one step, we're interested in the probability that the x bar is less than 175. So that means we're interested in the z-score that is less than negative 2.61, which is going to be 0.5 minus 0.4955, which is going to be 0.0045 is the answer I'm getting. So it's less than a 1% chance. Less than a 1% chance. And that's it. All right. Less than a 1% chance that a sample you take will have a mean less than 175. And that's it. I hope that was helpful. That's how you do it. If you have other questions from that chapter, send me the page number, the topic, the page number, and a question from the book.